Hello students. Today the topic is least cost method in transportation problem. This is a one-off method to find the initial basic feasible solution. Now let us see the problem. Find the initial basic feasible solution to the following transportation problem by using the least cost method. The data are A, B, C represent the rows and from and D, E, F represent the column. Available and requirement are given. The availability are 250, 300, 400. Requirements are 200, 225, 275, and 350. The cost elements are given. The first condition, it is a necessary sufficient condition for the transportation problem is supply and demand equal to or equal or not. We have to check out. The available represent AI and BJ represent the demand. That means requirement. First, you have to check what AI or BJ are equal or not equal. First, you have to find the AI total 250 plus 300 plus 400. So 750. And BJ total 200 plus 225 plus 275 plus 250 equal to 950. So it satisfied the condition AI equal to BJ. So this is the balanced transportation problem. Is most important condition for the transportation problem. We move on to problem. Least cost method. Least cost method means you have to allocate the value. First, you have to choose which place you have to choose. You have to choose the least element in the cost element matrix. Which one is least element? Even two elements are tie up. We can choose distant or distant. There is no problem. I can choose first one. So first one I choose panna and we have to choose the corresponding minimum of AIBJ. The corresponding AIBJ value is 300, 250. The 250 is the minimum one. So you have to allocate the 250. Again, you have to cancel 250 minus 250. It's a demand is nil balance and 300 minus 250, 50 is balance. Which one you have a nil balance means balance is zero. You have to strike out that row or column. So 250 is it's a nil balance. So fully strike out, allocated. So you have to cancel that column. Again, you have to choose the minimum cost element. Next minimum cost element is 11. You allocate that place. Then you have to choose the minimum of AIBJ. So minimum AIBJ is 250, 200. The minimum is 200. You have to allocate 200 that place. So 200. So 200 minus 200. Demand is fully nil balance 0. And 250 minus 200, 50. In this place, demand is nil 0. You have to cancel that column. Which one have a 0 balance? You have to cancel that column. Each and every term, you have to allocate only the minimum value. Most important one. Next minimum value is 13. You have two place. We can tie up the two 13. So we can choose this 13 and that 13. There is no problem. I choose first one. Then the corresponding minimum of AI by BJ 50, 225. The minimum is 50. They have to allocate the minimum value on that place 50. So 50 minus 50 is 0 because 50 is allocated. So 220 minus 50, the balance is 175. So in that time supply is nil balance. So you have to strike out for though. Again, you have to choose the minimum value. Next minimum is 13. Then choose the minimum of corresponding AIBJ value 400, 275. The minimum is 275. You have to allocate 270 on that place. So 275, 275 demand is 0. And 400 minus 275 balance is 125. So demand is fully allocated, utilized. So you have to cancel that column. Each and every time you have to allocate only the minimum cost element. Next minimum is 18. The corresponding AIBJ value 50, 175. The minimum is 50. You have to allocate 50. So supply 50 minus 50 is 0 and demand 175 minus 50 is allotted. So 125. In that time, supply is fully utilized. Zero balance. So you have to strike out supply. Again, we have one place 24 only cost element is available. So 120 minimum of AIBJ is 125, 125. 125, 125, you allotted 125. You have to strike out row wise 125. It's a nil balance. Column is full balance. So there is no balance available and demand fully utilized. So you have to strike out row wise and column wise. The values are fully allocated. This is the least cost method table. All supply and demand values are fully allocated. And next condition is most important condition. Degeneracy and non-degeneracy checking. M plus n minus 1 equal to number of allocations. M equal to number of rows. N equal to number of columns. And m plus n minus 1 not equal to mean it's a degenerate problem. And next final cause, this we have to check out this. So m plus n minus 1 equal to number of allocations. In that problem, we have 3 rows and 4 columns. Therefore, 3 plus 4 minus 1 equal to allocation. Just count 1, 2, 3, 4, 5, 6. So 6 equal to 6. So this is non-degenerate problem. The initial transportation cost equal to just multiply the value into allocated value. 200 into 11, 50 into 13, 50 into 18, 250 into 10, 125 into 24, 225 into 13. So I'll add these values and the initial transportation cost is equal to 12825. Thank you.